What you see here is a Hero 1 2000 robot arm that I purchased a while ago, and most of the motors seem to be working. The four main motors, at least, seem to be working. And I tested the encoder boards, and they seem to also return counts. So that's a good thing. I've been able to move the arm, the shoulder arm, shoulder motor up and down, and I've been able to move the elbow and also the wrist pivot. So those are the three motors that seem to be working the best. Two of the motors are a little bit stiff. They need to be either cleaned or lubricated, or but they're a little bit stiff. They need some work to make it really run smoothly. In addition, a couple of the encoder discs have cracks, and they would need to be replaced or 3D printed. There's some people online on eBay that sell the encoder discs for the Hero 2000, or you could just use a copy of the ones you have there and 3D print them, or even cut them out of plastic with an X-Acto knife. The ones that are there right now do return all the counts correctly, but like I said, there's the little edge on the encoder wheels on some of them are broken off. But I do have two spare ones that came with the arm. Unfortunately, one of them has a slight crack in it, but they could be used, and they're in pretty good condition other than that slight crack, which you could glue, I guess, to make it really rigid. But the encoder boards are working. They return counts and everything, and I've been able to get the arm working even though I don't have a Hero 2000 arm driver board. I used my own test rig that I devised with some special gear that I came up with to control all the motors. This arm could also be used with the original Heathkit training arm. It's almost identical. I've looked at pictures of it and it looks almost identical. So if you have one of those that just doesn't work, you could probably replace it and connect it to the base, the azimuth base, and probably get a working arm that way. But this arm really belongs inside a Hero 2000 robot. It was an accessory arm that you purchase separately, and it goes in the front of the robot if you don't have one. Here's a close-up of the encoders. These are the encoders on the left side. This is the wrist and the gripper. I was able to get the wrist to pivot up and down using the wrist right or the wrist left motor, and that seems to be working pretty well. I have not been able to get the gripper motor tested, or even the encoder for it tested, because that's a more complicated circuit board, and I didn't want to take a chance of damaging it. And I couldn't access the motor directly. There was no easy access like the other motors. So that one I basically don't know what the state of it is. But if it's like the other ones, it probably does work. The gripper motor just is a small motor that opens up and closes the gripper under pressure. It's a pretty sophisticated gripper, and it has a pressure sensitive board that came with the Hero 2000. But I can't really confirm whether that one works or not. These are the electronics that I'm using to test out the It's my test rig. I use my a VEX Cortex and a HB25 Parallax motor controller to drive the arm. Right now it only drives a single channel. Basically, I can drive the shoulder or the elbow or the right wrist left or wrist right or a wrist pivot separately by changing the cable. I would need at least 5 controllers to fully control this robot arm. And if you were going to do make one for the trainer arm, you need 6 controllers because you need one for the azimuth. And you also need the gripper motor too. Here's a view of the other side of the robot arm. What I'm going to show now is how I can remotely control this Hero 2000 robot arm, which was built in the 80s for the Hero 2000 robot. It was around 86, somewhere around there, 85. And it was a professional version of the Hero 1 robot, the very popular Hero 1 robot. These heavy-duty Hero 2000s were used for more university and colleges because they're very expensive, or they were used for robotics training and technical training, just like the trainer arm, which is almost identical to this, except it has the azimuth base that allows the arm to move from 0 to 360 degrees. In fact, I could have made an azimuth arm for this, an azimuth platform for this, pretty relatively easily. But my application was the Hero 2000, which is what it was going to be used for. The VEX game controller is what's used to control the arm. Given enough motor drivers, I could control every single motor using this remote control right here. It's similar to a Sony PlayStation controller, and it also has a key, Wi-Fi key, which is called VEXNet, which is Innovation's first version of Wi-Fi. It's just that they use a special version for competitions and everything, so they don't interfere with each other. But other than that, it looks just identical to a Sony PlayStation game controller. And each button can be mapped to move any particular motor, and the joysticks will move the arm or the elbow or the gripper to whatever angle you want. You have to be very careful, though, not to overdo it and not to do it too quickly, because otherwise you could hit the mechanical stops and damage the arm. You have to be, so if it starts getting close to its mechanical limit, stop and reverse direction. The limit switches would do that for you, but then you need to do programming to develop scripts and be able to use the limit switches, which would automatically stop the motor if it hit one of the limit switches. Similar to the 3D printer limit switches, when they reach the end of the axis, they stop the motor and then back away a bit. Now I'm going to use the 12-volt battery to power this robot. Usually use the power supply on the Hero 2000 or the very heavy-duty power supply that comes with the Heathkit training arm. In order to connect to the controller, the VEX Cortex controller that moves the motors on the Hero 2000 arm, you have to first sync to it. And so that's what I'm doing right now. You can see now that it's synced when it gets 3 green lights. That means I can remotely control this robot from quite a distance, whatever the range of the Wi-Fi is. Right now I'm about 8 feet away from it, but it has a good range. You could probably be 20 feet away from it and control the arm. And that is a very good idea because you don't want to be anywhere near the workspace of a robot arm, because this arm is very powerful and it could injure somebody. So you really need a clear space and operate the arm remotely like I'm doing. The original Hero 2000 robot had a different type of remote control that was designed for it, but I'm using this Vex Cortex now to control the robot arm. I also use it to control my own Hero 2000 instead of using the original one, which doesn't work anymore. Okay, I'm going to attempt to move the arm right now using the joysticks on the remote control. See it moving down, and then I can move it up. Down, up. It's very flexible. The noise you hear is the encoders. They're a little bit warped, and so they bang against the side a little bit. So I shouldn't do this very much. They really do need new encoder wheels. These encoder wheels, like I said, are found on eBay, or like I said, you could 3D print them or even cut them out of plastic yourself, as long as they match the form factor that the pattern that they're on right now. See, I can close it quite a bit, and I can stretch it way out. Got quite a good reach. Alright, I'm going to try moving the, pivoting the wrist now. See the wrist there moving.